Right, this video is going to talk you guys through how to use sheet metal mode in Inventor, which is a quite handy tool that allows you to basically make a folded up part from a flat net. So a bit like you might have done in modeling stuff out of card, cut out a net, fold all the corners and edges and stick them together. You can kind of do the same process but in 3D. So I'm going to show you how to make a couple of objects. We're going to make something similar to this, and then I'm going to make something a bit more awkward, like a pyramid design that folds up. So the first thing that's really cool, I'll just show you the end result. This is what we're going to build, and if you can imagine, this could actually be made and folded and then perhaps solvent glued together to make a construction. Kind of surpassed with 3D printing and stuff nowadays. You maybe wouldn't make that many folded boxes, but there are certain times this might be useful. What's really cool though, you can just click one button here, look, go to flat pattern, and then it will unfold your contraption into an outline that you could export to the laser cutter, and you can see exactly where you need to fold. And what's even cooler is if you click bend order annotation, it will tell you the recommended order to make the folds in. So number 1, number 2, 3, 4 and 5, because as we talked about in previous lessons, if you're folding up a 3D construction, you've got to think about the order you do the folding, otherwise it can all work out wrong if you get the wrong fold done first. So anyway, we're going to make this. Now, I'm just going to close that for now. You want to start with the standard part. Okay, again, you can do this within an assembly if you want, but I'd say start with a part. And before you do anything else, up here you'll see on the right there's an option, convert to sheet metal. So click that, and this will now make this a part that is a sheet metal part. There's a difference between a part and a sheet metal part. Save it, obviously, so you've got it for future reference. So I'm just going to call it delete me, but you know, save it, whatever. And really, you start by specifying the material you're going to use. This is important because it works out all the folding based on the material type you put in. So if you go up to this one called sheet metal defaults, and you can say you can choose by sheet metal rule under material, and you'll see there's a whole bunch of materials there, and these are pre-programmed into the program to account for the necessary folding radiuses of those particular materials. So for instance, something like steel would require a different angle of or amount of bend as a piece of plastic might do. This has all been worked out by scientists and material engineers before and programmed in. So pick your material. Now, if you were using acrylic at school, the actual name of acrylic is polymethyl methacrylate, which is this one, PMMA plastic. And we use millimeters here, so I'm going to change it to default millimeters. And I'm going to set the thickness to 3 mil, which is the thickness of acrylic we use. Now, if you were doing this for your own work, you might be using 1 millimeter aluminium, in which case you'd choose aluminium and you'd set the thickness to 1 millimeter. So basically set this for the material you're going to be folding up. Click apply, and that's all you've got to do, okay? Right. You then start by drawing a sketch for your starting place. Okay, so I'm going to start a sketch, doesn't really matter where, and I'm just going to draw myself a rectangle, nothing fancy. Let's just go 50, tab 100, enter, just zoom out there. Okay, 50 by 100 rectangle. If you've forgotten, by the way, remember you can zoom in and out by scrolling the mouse wheel, or you can click and hold the mouse wheel to pan your view around. Okay, so make yourself a rectangle, finish, and then you're going to choose face. So click face. Now it automatically knows. You'll see it's automatically dragged it up 3 millimeters because it knows that's the amount, and that's fine. Just click apply. Okay. Now at the moment, my acrylic, it's picked a transparent version. So to make it a bit more visible, I'm going to go up here and change the material to red, just so it's a bit more visible for you guys. And this is where the magic comes in. Right, we know that if we were making a folded box out of this, it would have maybe a fold here, another one coming up off this edge. They're called flanges for the most part in sheet metal mode. So pick flange, and it's saying pick an edge. Now if you click that edge, for instance, on the top, you'll see that puts a ghosted image of what the fold will look like. Now you can set things here like the height, so let's say we want our flange to be 50 or 30 for instance, and there are some other options. So you can choose whether it takes the measurement from the start of the curve, from the middle of the curve, or I think from the end of the curve. I tend to leave these as default, and you can choose whether you want to add material, so your fold starts there or halfway or flush or whatever. Okay, so play around with those until you're happy with how the fold looks. I'm going to leave it on that setting. Okay, no, I'm going to leave it on that one. Okay, and then click apply. That's easy. I could do another flange on here. I'm going to do it the same way. Now, just if you needed to, you can click this one, look, which flips it. So if for some reason you were making a stepped affair and you needed your acrylic to fold in 2 different directions, then by all means choose that. I want it to go this way up though. Click apply. I'm going to put 2 more flanges on these, so I'm just going to click flange here. Now, this is where you might want to play around with what you do on your folding. All right, you might decide by clicking that you want your folding to actually happen inside, so it ends up flush. You might want it outside. Maybe you want it to extend up to the edges of these. I don't know. I want mine inside so that I can glue that side to that bit here. So I'm going to pick this option, and I'm going to click the little arrow down there. And what you've got is the width extents. By default, it gives you a little bit of a gap look, which is great for making it easy to fold, but not so good if I wanted to glue this bit to this bit. What you can choose, and I've not quite figured this out, is you can choose offset. So if you type offset, look, type, I don't know, 0.2 and 0.2. Now that's not quite done what I wanted, sorry, I remembered now. So go from and to and pick one face and pick another face, but don't click apply. Then go back to offset, and there we go. Leave it at 0.2, and can you see that's put, look, if I change it, 0.5, 0.2, that's put a little gap between them. Click apply, and you can see what that has achieved there, another folded corner. I'm going to do the same on this guy, flange, click there, it's already inside, expand that, from and to, so from there to there, set it to offset, 0.2 offset, click apply. There we go. Okay. So I've got 5 out of 6 faces done. I just want to show you what you can test as you go along now. At any point during this adding flanges process, you can click this button, create flat pattern, and it will just unfold it. And what it will actually do is automatically figure out where you need to make cutouts. These cutouts are necessary to allow the bits of material to bend past each other when being folded. This is what I mean when it automatically calculates the size of those. If you want to go back to the folded model, you just click go to folded part. So flat pattern, folded part, you can look between them. Okay. Now, I'm going to do the top piece as well. So I'm going to put another flange, and I'm going to click, don't really matter, like that. Now this is folding the wrong way, so I'm going to flick that. I want it to go the other way. Distance, I don't know, 55, 59. That's overlapping slightly. Okay, so I don't know, 58. There's a certain amount of playing around, 0.8. That looks about right, 58.8. And I can see my width is a problem. It's going to overlap these side panels. So I'm going to expand that again and go from and to. So from there to there. And then we need to leave a gap. So I'm going to put offset 0.2, 0.2. Okay. Here we go. So I have made a box that folds up. You can imagine painting glue or solvent glue in the gaps here and bonding this together if you needed. I can go back to flat pattern and see what it looks like. And what's also useful is I can now start to add my features in. So if I knew I needed a hole in this face for a screw or something, or for just a switch, I could make a new sketch on there like I would do any Inventor model. I don't know, I'm just going to make some box contraption, some kind of slot. I don't know what these are for. They're just to illustrate. Finish them, and then the only difference is you'll have to go to 3D model to find your extrude thing. Click the things you want to extrude, cut them out. There we go. And again, if you go back to sheet metal mode and click go to flat pattern, you'll see that it would laser cut those out as well. So hopefully you can see the value of that. You could, obviously you can't fold wood, but we can fold acrylic at school. We can also fold sheet metal. Now we can't laser cut sheet metal, but if you wanted to if you wanted to fold an accurate metal box, what you could do is spray paint a piece of aluminium with a coloured spray paint, put the aluminium in the laser cutter, engrave all these lines through the paint into the aluminium, then use those lines on the aluminium to cut out with the guillotine and with the hand shears, and then use the sheet metal press to fold them around those corners. So there are ways around it if you want to work with metal at school. And I had an A-level kid in the past make a box out of aluminium for he wanted to make like a thing that fit an electric skateboard, so all the gubbins for the electric skateboard fitted in an aluminium box that went underneath, and we did it this way. So anyway, that's sheet metal mode. That's how you just do it with the flange tool, and that's fine. I'm going to close that. All I'm going to do now is show you how to make more awkward shapes, which I want you to experiment with. I don't want to save that, so I'm going to make a new part, convert to sheet metal, start sketch. Okay, sheet metal. Right, I'm going to start by, no, I didn't actually specify the material, so I'll just go back. So the material, we're going to go PMMA, millimeters, 3 mil. Okay, make my base sketch. Right, now what I'm going to try and show you is how you can make your own folds. So I'm going to start with a rectangle. Okay, I don't know, all right, let's make it 50 by 50. Okay, and I'm going to finish it. I'm going to extrude it. In fact, I'm going to make that a face. There we go. Change the color. And what I'm going to do, I'm going to go to 3D model, stick a fillet on these corners. 1, 2, 3, 4. I don't, just make them a bit bigger. I'm just sort of messing around here. I don't really know what this is going to be, by the way. Right. And now what I want to do is I want to fold all 4 corners up, but I haven't got, I want to fold them sort of where I'm tracing the mouse, but I can't do that with the flange tool because flange will only let me pick an edge. So what I'm going to do is make a sketch on the top, and I'm going to draw a line from midway along there to midway along there, finish sketch. Okay, you have to do this one line at a time. Then I'm going to choose bend, and I hope this works. So it says pick the edge. It didn't work. Oh, that's annoying. Or maybe it's fold. Fold. That. There we go. Okay, so I want to fold there. And now these arrows dictate whether it goes down, up, in, or out. Now I hope this works. There we go. Fantastic. That's what I was trying to do. Okay. So I'm going to do that again on this side. So I'm going to make a new sketch, draw myself another line. In fact, I'm just going to do it from here to here. 1, 2, finish the sketch. And I'm going to, which one was it? Fold, I think. Fold that. Now it's going the wrong direction, so I want to flip that. So it's going to come up and facing that way. There we go. So hopefully you can see that's another way you can fold the material. I think again, if you click create flat pattern, it will unravel that and it would give you these marks that you could engrave on there. But it's just another technique. Now, I don't know how clever it is, as in I'm just going to attempt the impossible now and draw a line from here to here. Oh. And I'm going to attempt to fold that. I don't think it likes that. Let's try that again. I think the line has to extend from part of the object that's very much there. Right, it has to actually be within the extents of the model. This may not work. I haven't tested it. Fold. No, or bend. that doesn't work. Okay, so I think just like in real life, if you think about it, you couldn't actually fold this in half without ripping this piece in two. So you can't. You could put another fold in here possibly. I might try that. I don't know if it's possible. Something like that. Fold. There we go. And there we go. That's possible. But you know, not. It can't. Basically, it can't fold anything that you couldn't actually physically fold in real life. There are all sorts of other options here I've not played around with. Like if you hover over them, contour flange looks quite lets you draw it from the side and then unfold it afterwards. Lofted flange looks very interesting. I've no idea, but I think you can. I think it will allow you to make a shape like that and unravel it afterwards, which would be damn cool if it's true. But I'm not going to go into that in this video. I'd encourage you to play with that on your own. Okay. So anyway, thought it might be useful for some of your projects that you're doing at A level in particular, and keep it if it's useful. If not, learn it, put it on the shelf.